Hello and welcome to the Daily Space. Today is Wednesday, September 2nd, and I am your host, Annie Wilson. Most Mondays through Fridays, our team will be here putting science into your brain. Usually Wednesdays are for Rocket Roundup, and today is no different. Let's get to it, shall we? First up, on Sunday, August 30th at 23:18 UTC, SpaceX launched a Falcon 9 carrying 3 satellites to a polar orbit from Cape Canaveral. This is the first East Coast polar orbit launch for SpaceX. The main passenger for this flight was Argentina's Falcon 1 Bravo, with rideshares Tyvac 1072 and GNOMES 1. The Earth observation satellite Falcon 1 Bravo weighs in at about 1,600 kilograms. That's like 800 2-liter soda bottles. It's the second in a 2-satellite constellation. The first was launched in July of 2018. Developed by Argentina's space agency CONIE, it will image the Earth's surface using an L-band synthetic aperture radar, allowing detailed images to be taken day or night and in all weather conditions. It joins Falcon 1 Alpha, which was also launched into space aboard a Falcon 9 rocket back in October of 2018. Not much is known about Tyvac 1072, except that it was built by, Tyvac. And it is definitely a microsatellite, as that's what the company specializes in. GNOMES 1, or wait for it, Global Navigation Satellite System Navigation and Occultation Measurement Satellite. Yes, that's an acronym in an acronym. Is owned by Planet IQ. It's the first of a planned 20-satellite constellation that, according to the company, will collect my apologies. Let's try this again. Will collect radio occultation data for weather forecasting, climate research, and space weather monitoring. What that means is that the satellites will measure signal strength coming from those global navigation satellite systems. Even though all of these satellites are in space, their signals can still be partially blocked by the atmosphere. GNOMES 1 will literally measure how much the atmosphere is blocking the signals. This is most effective when the signals received from satellites are at a low look angle and have passed through the bulk of the atmosphere. Changes in the signal strength can indicate cloud and storm formation. The biggest change between the GNOMES constellation and older radio occult weather satellites is that the satellites are capable of receiving signals from the US's GPS, Russia's GLONASS, Europe's Galileo, and China's Beidou Global Navigation Satellite Systems, otherwise GNSS. Okay, for those of you keeping score at home, this was the 4th flight for this first stage. In a press release, SpaceX shared that it had previously launched Dragon to the International Space Station for SpaceX's 19th and 20th commercial resupply missions, and it also supported the launch of SpaceX's 9th Starlink mission. As far as the fairings go, no catch was planned, but Ms. Chief did successfully retrieve both fairing halves from the ocean. The launch of Falcon 1 Bravo and Company was significant in terms of the track it followed, since the payloads were destined for sun-synchronous orbit, otherwise known as SSO. That meant the rocket needed to turn due south from the launch site, taking it over Cuba, among other places. This is the first time it has done so from the Cape since a launch in 1960 caused debris to land on the island nation, killing a cow in the process, and prompting protests in front of the U.S. Embassy there. The FAA and range safety officials approved this launch profile for SpaceX for 2 reasons. First, the Falcon 9 uses an automatic flight termination system that can activate without outside radio signals in case of an emergency. This is useful since ground base's signals would have to be received through the rocket trail left behind during the launch. Second, since the first stage was able to land back at the launch site, there was no debris which was likely to fall on places downrange in the first place. And yes, we have rocket launch video. And yes, it is loud. Please mind your ears. That's venting of
T-minus
locks.
15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff of Falcon's first East Coast polar launch, Ola, Argentina.
Stage 1 course nominal.
All right. And because it's SpaceX, when there's a launch video, there's a landing video.
During this period, the landing legs will also be deploying. You might be able to catch it right before
You
we
will be
touch
able to
down.
catch it.
They're stowed at the base of the vehicle and made up of state-of-the-art carbon fiber and aluminum honeycomb.
So
Stage 1 transonic.
I love this. You'll see it in a second, but
You can see the cape getting closer and closer.
the
what a
grid
cool
fins
view.
literally cut up the clouds.
The first stage is passing through the cloud layers right now.
Stage 1 landing burn startup.
And here comes Falcon 9 attempting its fourth landing.
The legs will come out shortly.
Stage 1 landing leg deploy.
Ta-da!
And you could not ask
Stage
for
one
a
landing
better
burn.
landing than that. Falcon 9 has landed once again. That is number 4 for this first stage booster and the 58th overall of an orbital class rocket. What a way to start off tonight's mission.
Nice. Next up, Rocket Lab's 14th Electron launch. I can't believe it's not optical. Launched on Monday, August 31st at 3:05 UTC. Its payload was the Capella Sequoia, an Earth observation satellite that uses synthetic aperture radar. According to Rocket Lab's press release and mission overview, the satellite can provide high-quality images of the Earth day or night and in any weather conditions, providing insights and data that can be used for security, agricultural, and infrastructure monitoring, as well as disaster prevention and recovery. Sequoia is the first in a planned constellation. And we got rocket launch video.
T-minus 20 seconds and counting.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Liftoff.
Picture of it.
Excuse me. Okay. And this is the return to launch flight for Rocket Lab. Previously, they had a problem with the battery hot swap, and the 13th mission, which was called Pics or It Didn't Happen, there were pictures, but it still didn't happen. So I have a bit of video from the battery hot swap of this flight.
Hot swap successful.
just to share the little bit of joy that they got from their return to flight. Okay, so a couple of the satellites I've mentioned today use synthetic aperture radar, also known as SAR, sensors rather than optical sensors. Unlike conventional optical sensors that use ambient light, such as the teeny tiny little camera on your smartphone, synthetic aperture radar emits radio pulses to illuminate a target, scene, and antenna that is moving because the spacecraft that it's attached to is moving. Records the time it takes the radar pulses to return. It's the change in position of the antenna from when it sent the signal to when it receives the signal that creates a large synthetic antenna aperture. Wow. Effectively creating a much larger antenna than the size of the physical receiver. The larger the aperture, the higher the image resolution will be. These systems aren't affected by things like whether the target is illuminated by light or obscured by fog or clouds, which can significantly increase the amount of time they can image. The collected data can be used to create two-dimensional images and three-dimensional reconstructions of objects such as landscapes. In many ways, SAR and side-scan sonar systems are very similar in that both systems emit the energy used to image the target of interest. A few applications of the technology include sea ice monitoring in the north, disaster response, environmental monitoring for things such as leaking ships and oil wells, topographic mapping, and the tracking of ships. All right, to wrap things up, here's a running tally of a few spaceflight statistics for the current year. There are currently 3 toilets in space. Humanity has burned up 2 toilets in the atmosphere this year. There is a whopping 695 satellites that humanity has put into orbit. This includes those launched from other in-orbit craft, such as the International Space Station. 679 of those satellites came directly from launch vehicles, and 533 are Starlinks just this year. There have been 67 total launch attempts so far this year, including 7 failures. I keep track of orbital launches by where they launched from, also known as spaceport. Here's that breakdown. China 23, USA 22, Kazakhstan 6, New Zealand 4, French Guiana 3, Japan 3, Russia 3, Iran 2, Israel 1. Your space fact for the week comes to us from Keeper of Maps, otherwise known as Gordon. Maple syrup cookies were one of the official food items sent up to the International Space Station for Chris Hadfield by the Canadian Space Agency. And yes, he shared them with the other astronauts. And that rounds out our show for today. Thank you all for listening. I have been your host, Annie Wilson. Today's script was written and edited by Dave Bullard, Gordon Dewis, Allie Pelfrey, and myself. Our web content will be produced by Beth Johnson. Our executive producer and fearless leader is Dr. Pamela Gay. The Daily Space is a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are here thanks to the generous contributions of people just like you. The best way you can support us is through Patreon at patreon.com/CosmoQuestX. Like us, please share us. You never know whose life you can change by adding a daily dose of science.